view on this thing. Let's do this. We just need to do all the other parameters for the rest of this. So I guess we're this one we should be able to wrap up pretty quick. So if I just go back and review what I've got to do is just build the rest of this, which so yeah, I guess there are some particular things to look at. Let's see. So I think I can just start with I think I'll pencil in or I'll visible line in the clearance hole for the part X, and I'll worry about this last here. So if I zoom in here, what's going on a little bit maybe is really what I think what I'm going to do is extend in the so it's extending the major diameter a little bit, and then it's extending the minor diameter, and maybe I'll go to that Appendix B thing that I added and see. I think I have some information on what this would be. I really feel like the pilot hole depth, yeah, and the I think what I really carried through, I don't know, I can't remember if I carried through the internal type thread stuff or if I've carried through the external. So this is kind of a little bit confusing, and you have a hard time telling what's lined up here. Because if you think about what could be, what these could represent, is either the external threads of the fastener, or is it actually carrying the information for the internal threads, like kind of the major and minor of the internal threads. And so that's kind of the question. And also considering that there's like a pilot hole depth or a pilot hole. So I don't know. There's some particular things we need to, and it's not that I can't remember how I did this last is one thing. So I'm going to kind of step my way into this carefully. Let's do. I know what I can do easily is the top view, and I can even do the kind of get the material. I don't need to do the sectioning maybe yet till I kind of figure out what's going on here. But I can definitely at least do my break lines and kind of finish off the outside parameter of this, and I could do the section view for or the sectioning for the upper piece, this part X, and the clearance hole. What's going through it is there's that clearance hole, and so. And it will take a little longer because then we have to go to the drawing and do a bunch of local notes and notate this too. Um, so let's just I'll just focus on the next part, which is to me is like part X right here. So what part X has going on is that it's well, it's visible line work. So I'll get over to my visible line layer here, and I'm just going to draw in at least maybe I'll wait on this the outer perimeter of this here, but I think I'm going to say well it just goes here. Um, I could draw it across all the way. I know I'm drawing line over line a little bit. My head has a line there too, but I'll draw this over and then I'll draw the other horizontal line. That is the part thickness. It's like 0.38 thickness here. And then it kind of and then it kind of terminates, or I need to show the clearance hole. So I won't, it's not gonna, this has to, that clearance hole should be shown here because I'm at section anyway. So the clearance hole is going to be shown as if I've sectioned through, like I haven't sectioned my fastener, but I've sectioned through the materials here. So the clearance hole is going to show up as a visible line. It should be a little bit bigger than the major diameter, right? Because it's that weird, odd dimension on what I'm showing is the clearance hole through the part. So what I have is this clearance hole in part X is 13/16 in diameter. So I'm gonna pull that up and say, well, what is 13/16? We already did this once. It's 0.1825. Wait, 0.18 or 0.8125. So that's what I want is to know to offset that. Each side of center is what I think I'm going to draw. So I'm going to divide this by 2 so I can just do an offset there. So if I offset from center where my bolt is, I can show the clearance hole visible line there. So at 0.4062. I'm going to go back over here. I don't say I have a really good thing to offset other than some pretty long lines. And so I might just, for just ease of this, I'm going to do a construction line that's just, I only need to show the clearance hole through this part. I just drew another little construction line over here. And then I'm going to offset that weird dimension, 0.40625. So I'm going to say 0.40625 is my offset dimension. And I'm just offsetting this piece of geometry here because it's easy. See, that's going to be the edge of that shows the clearance hole through, that shows the clearance that the fastener has, which I think we determined was about a 1/16 of an inch. But how I think of that is I think of it, yes, it's 0.06, like larger than the fastener size. But really, I think of it all the way around. It's only half of that. So I think of like clearance holes in there in the Like how much room is really all the way around it? Well, it's actually like 0.03. That makes sense. That could confuse you, but I think of clearance as like all the way around the fastener. How much clearance? Well, it's actually 0.03 all the way around. If I push the fastener clear to one side of the hole, yes, I could then move to the other side and say it's 0.06 larger than the major diameter. Anyway, I'm in the weeds a little bit here, but essentially I'm tracing over, or I could just change this to visible line. So I'm just going to match the properties of the major here. So that is the clearance hole through part X. This would then be sectioned with material, and we can do that real quick because I do have a boundary. Like I have, this is a closed polygon by here, but maybe I'll wait and do the section just for a minute. Let's finish off like the overall, um, at least from this is all just construction in the head here. So the material really starts right here and goes down through. So I think I'm just going to show that as visible line work or sectioning. No, I do have like a broken. I don't think we've used this yet. Like my short and long break line, because essentially those are kind of break lines in that picture. The little zigzag, little Z shape. What I'm talking about here is this. If I look at the picture, the way they've drawn it, I'm kind of just replicating this. They put in these little break lines here. So I'm going to use my short and long break line. I'm going to use the short one. This is kind of a short break. Long would be for like a really long, like a 20-foot long something, or I don't know. Yeah. And I think there's a quick, I think there's a in a menu somewhere or on a palette somewhere. Maybe we haven't used this either. I think there's already some of this like blocks that are that I can pull in. These like little zigzaggy break line things. Let me see this. I'm there's some brain cells dusting off here. Let me go over to my CAD. So really what I want is to like draw this with like some break lines in it, likely on this layer, this like this short break layer. If we look at what, since we haven't even used these, if we refresh our mind here, or refresh, look at our layers again, we had a break long layer. It's continuous and it's a light line, and it's for long break lines. Then we have a break short. This is continuous as well, but it's a little bit heavier. A little bit heavier line weight is the only difference, and it's for short break lines. So let's say why I know ASME. I can't off the top of my head, I can't remember why I have a line type difference, other than it just definitely separates those two different break lines by line weight. But and then the other thing I want to dig for a little bit here is if I have a quick access to inserting that like little break symbol, and I think it is in here, but I don't know if it's like in my insert here. Let me dig for just a second here. I think there is. I think I have access to something. Can't remember where it is though. Because I don't think we've used it yet this semester. Oh, I think it's going to be here on my view tab, maybe. And on this tool palettes. I don't think we've pulled this down yet, right? But maybe you use this in architecture a little bit more, because let me pull this down. It has this, mine is docked right now, so I'll move it, and it's really kind of a weird shape. So I'll adjust my shape of this little block. It's kind of weird. I don't know if yours will default show like this too, but I can kind of maybe make it a little bit wider. I don't like how narrow it is. Just kind of want it like this. Oh yeah, yeah. So this is just like little. I think this is loaded just in default CAD. I don't know why I'm on. I don't know what panel I'm even on here, but it has all of these little like file tabs here. I'm on low pressure sodium for some reason. I don't know. Maybe I clicked through here one time and it just remembered this is where I was. I don't know where yours would open, but if I start at the top tab, I want to say in architectural you'll use this maybe more than we use it in mechanical. This kind of these tool palettes that are already loaded in. But they have some symbols that are already created for us that we can bring in kind of as blocks essentially. And some of them, I think with the lightning bolt means they're an annotative type block, I think. So they'll kind of automatically size for on our sheets. But so this is structural. This is a structural tab. So there might be some quick things to apply to a structural print. And then what else they have? So they have some hatches, different hatches. Definitely use this in architecture, right? Because you're using some of these bricks and other type materials that are maybe a little bit different than what's on the actual hatching. It could be in addition to what's just loaded on the hatch tab. Tables, okay, there's a few different types of tables. We have some commands, I think, and then leaders. Oh, we got different types of leaders. Oh, there's our normal commands here. So modify. I think it actually shows Some of it's just what's loaded on those pallets here because they are the tool pallets. So there's, I think they're just showing some of the expandable stuff and some pallets I don't have loaded on my home tab or whatever. What is this one? Just like this is generic lights, fluorescent lights. Okay. It's kind of interesting to see what these things are. I was thinking there was a mechanical one though. Why am I thinking wrong? It's Oh, I have like weird. Oh, yeah, yeah. So I just had some that are buried under. Like I have like my thing isn't big enough, I guess. But yeah, mechanical. That's right. What I'm looking for, right? Uh, Maybe it's not on there though. Oh yeah. So let me look through some. I don't know what else. Maybe I'm thinking. Maybe I'm wrong. But I could swear that there was. It will definitely show up, right? It will definitely show up. And maybe that's what I did. Maybe I'm thinking. I was thinking there was like a place to look. Just type it in, just like in your like if you were in here, if I'm in my typing break, I might have to close my menu here or get out of my command. Break line right there. It does show up if you type in break. I was trying to find it if it was in a tool palette already, but there's break line. Okay, okay. Maybe that's how I drew this. I can't remember. Either way, you can type in break line. I was thinking there was a little like it could be in my blocks. It might be, I don't know. It might be on my blocks palette. But um, but your blocks would be different probably than my blocks. Oh, I do have one. Why do I have one? I don't know if you guys do. If you go searching in your blocks, you may not have. You probably don't have the stuff I have because mine will keep mine. And maybe I blocked. I don't know. Let's just try typing in block and see if I or break line and see if I can do this. I'm gonna be on my short break layer though, and then I'm gonna type in break line. I can't remember what this does though. I can't remember if this is weird. Oh yeah, okay, okay. I think what I do is it does, right? So if I go to here, if I draw this line and then I go to oh yeah, it does. Okay, okay. So it put a break in where I ended my line, right? So I'm gonna play with this and like oh yeah, yeah, yeah. So I selected midpoint, then it wants me to okay, okay. I should just watch my command line is what you should tell me. Listen to the command line. It's telling me what you want to do. Specify second point for break line. Specify the location for break symbol midpoint. I don't know. It's just random here. Oh yeah, right here maybe. Oh yeah, like this. Yeah. Oh, that's kind of, it is a weird command, huh? I kind of forget. I don't use it a lot. Yeah, I haven't decided how. It may not be. You could definitely block this thing. I can't remember if I turned it into a block and then placed it in. I mean, that gets a little annoying. Yeah, and so maybe how I would do this is I could probably just do a single break line. Like what I want really to do, I don't know. Let me just take a quick look on how they did theirs. So they definitely put a break in, kind of like this is kind of like a good case scenario. What they've shown is they put a break in on this material. I think they've strategically like because these are two different materials, it's nice to put a break line in here and then they put a couple in there. Whether you just have one in here, I think would be okay. And I don't even know if this will fit. Like let me look when you type it in. And I might keep a consistent size all the way around, but let me see. Break. Yeah. So this is like first point of break line, second point of break line, second point. Yeah, play with this for a minute. And this size here. It's one of your command changes here, huh? Size. Oh, it says it's too close together. Like to be able to do this there. Also, yeah. It's, is it a pain? Yeah, because if you didn't pick a size, it's going to pick like this big. Yeah, that's what I'm playing with mine over here. And you only get the size selection the first time out, right? If you're picking brake line, you can say size, and you can enter a size. And during it, when you're in there, he asks for size. Yep. This is the brake line symbol size. I don't know what you guys use. What you guys in a quarter inch or even smaller? 0.125, eighth inch. That let me see what that. Yeah, because I don't know if this will allow this to go here or will it maybe. It says it's still too big. I couldn't put a brake line in just this material thickness there if that's what I wanted. Okay. I like it. I like it. Yes, yes, yes. Yeah, because it is kind of a funny, it actually extends through here, huh? And you can probably place these back. I don't know if mine will fit here. I don't know. I don't know what kind of grips I have here. So I have to select all of these or what? Oh, man. Yeah, no kidding, right? Because it is a pretty complicated little line here. And I just, yeah, yeah. Because if you do go move, and I say move this thing by this point, really what I'm looking for is to create one that's somewhere in between here and there. Like this is what I kind of would like, my first one. Yeah, and it doesn't like that, no. Yeah, I know. I get it. It's kind of weird, huh? I guess I'm looking to kind of do like a little break here because that's one piece of material. So maybe I'll do another. So I've done exactly that. I've like clicked and moved that, and mine's an eighth of an inch, which works good for that. And I'll keep that the same uniform, but maybe I'll do two of them. So if I do that again, or even if I just copy this, right? If I've done one, copy it maybe by this endpoint, and then put it here again, and then I think I can extend this maybe down to the halfway point of somewhere, or even just here. Yeah, I don't know if I'm gonna love that though either. I might just go with one. This will take the rest of the time. Just about the great. I was thinking there was a block in those two, but I think I made a block or something. Yeah. And when you guys use one, if you go to insert a block, do you now have a break line as like one of your last? Does it show like? Does it show it now that you've like maybe used it through the command? Now it shows that you've got a block loaded. So maybe once you've used it once, it shows up in your blocks, at least until you're completed this one. It's interesting. I don't know if did you guys use that in architecture at all, or did you guys do break lines? Handmade them. Yeah, yeah. And I was thinking that I was a hack, and so I did it like this one. So you do remember. So yeah, so for those of you that don't have architecture history, you'll be like, I think I just need the great one. And then you'll get into it and you'll be like, oh yeah, I remember this one. It was hard for me to get like this. And then the order of operation. Well, yeah, that's the key is I think their ribbon is limited on what they can actually display because I think the commands and they've never like booted out any commands. So they've just added more commands. So I don't even know if there's ribbon menu space for that. I do like how this is. That's good. Well, I'm not even done with my break line, but I will. You guys could, yeah, that is the next thing. What I wondered is if, and it is pretty common that, like, I like how the break line does break out and beyond. That's pretty common that your break line doesn't have to like be bound by your. I feel like it's pretty common for the break line to break like a boundary of visible line or whatever. Like I was going to look at theirs again, top of my worksheet here. Pretty common like this. Notice how our break line is doing exactly how theirs looks from way back in the day. And so this is pretty common that your break lines would extend like it's building itself that way. Because mine is doing that. It's adding those extensions beyond where I actually pick the line end. It's like a preloaded extension, which I'm sure is adjustable on your properties palette there. I'm sure this like line extension that it's naturally doing is it's probably something if I bring up my properties panel again and I actually select that line. There's probably going to be some, I don't know, starts, I don't know. Not necessarily, I don't see it real clear. It just does its own extensions. I'm probably going to pull this one back to be extended so it matches down below. And then I'll do a couple more here. So I'll catch up to you in a second now that I'm off of one. You can just trim them. Pretty modifiable little brake line, right? Yeah, I like that I have to, it is like full. I got to remember to do my size first. And that always tricks me up before as well. So it'd be normal, copy this thing. I just wanted to get mine across the bottom, and now I want to just do a mirror of my other one. So I'm just going to mirror the. I like how I've got this one. I did mine in like three parts, I guess, essentially. That's good. I'm just going to use this as my mirror line. This line over there. So no, okay, I'm done. It does flip them the other way. I don't think so. That's a good question, but I don't think it would catch my eye at all. But that's good. That's a good point. Oh yeah, because then you would stay in the zigzag instead of mirroring the zigzag. Yeah, let's see what they did on their. I could say theirs is in the same orientation. So if you copied it, maybe you are more. But I feel like I don't. Yeah, I'd have to go to the theory book and deep into it. And be like, does it matter which way my break line zigzags are? Off the top of my head, I think no, it doesn't. And so, yeah, I think one thing that I want to do is I probably should have drawn like a visible line behind here because otherwise I'm not going to have a line that's like this is my only construction for me. So um, I don't know if you guys I never traced this, but I actually want to trace this is like the edge of my like I'm going to move this to front probably for myself. I'm going to bring this to front the break line. So but I just never trace that as visible. And on my print, I don't want because I had construction underneath it. When I go to my print, it's going to like not show material there. Should it be? It's a question. Should I have visible line there or not? Yeah, I guess. Yeah, it's true. Like, I mean, yeah, and I think it would be a boundary that would allow. So maybe I don't have to do that because really my boundary is going to be my broken material. Yeah, yeah, that makes sense. I've convinced myself I don't. So it will be kind of captured by the and I think this break line will still allow me to hatch it, right? So what I want to do is now hatch this. Let's see I haven't finished the bottom. I'll just hatch the top. So hatch this thing. I want to look for aluminum. So if I don't know what it is, well then I don't know what it is. The aluminum one. It was in the section chapter, huh? I can tell you what it looks like. It kind of looks like little lines with perpendicular lines coming off of it. So let me look at, and maybe it's listed. It might actually be listed as aluminum. I can't remember, but it's like I think it is a preloaded one though. They have it in the material types. Is it ANSI 38? Are you looking at your textbook? Are you looking here? Yeah, I can't remember if it's this one. I think it's this one. I think it's these ones that like intersect perpendicular to it. It's like ANSI 38. Are you saying we did sectioning last week in theory? No, it was before that. It's old actually. In the hatching or what? Just a donut. It's like a torus, maybe.
You never know when you don't.
We're actually going to draw.
Well, or maybe for the 0 calorie. It's beauty.
There's no depth to it. Sorry, I'm just looking up. I'm pretty sure this is aluminum. I'm pretty sure it's this intersecting. Like I don't have my hatching totally memorized, and I don't even know what in our.
Know that the foot hatchings are different than the world hatch.
Oh, that's true too. Yeah.
Well, don't do that. Be wrong in the mind.
Chapter 12, I think it's chapter 12 was when we studied chapter 12. It had a whole book, it had a whole page on like this section hatching. But you're right, it probably had, and that's probably something that slightly changes over time. Doubt it.
Because I was lazy and looked up.
Magnesium and magnesium alloy. In your book, it is kind of like this. It's like it's definitely ANSI 38, according to like our textbook. ANSI 30. And is that one on here? Yeah, that one is that one. It's really close to looking like steel, but it's got like a double line. This one reminds me, ANSI 32, I do remember is steel. And then steel alloys for sure. ANSI 31 is just our default, can be cast iron, but it's also just default for like materials, general purpose. ANSI 38 is what I'm using. ANSI 38 for here. That is the, and I'm gonna hatch this one at the same time here. Section layer, I sure do. I'm gonna also make it annotated as well. Just while you're in the hatch command, if you haven't closed it, you can choose it to be annotated, and then it will scale for us a little bit better. Yeah, and then of course I think we're gonna have to worry about like setting the other hatch when we go to do it, so that they kind of the lines don't line up, or we maybe go the pattern the other way. I think with aluminum it's a little bit tricky to do that because they are kind of both going both directions anyway with their. Yeah, this should definitely be on the hatch layer, or sorry, section layer. Should be pink. Yeah, magenta. Like that looks good. I think technically my construction material has caused my hatch to be not correct though. So I'm gonna turn off my. I think I can change that, but I can definitely make sure that I'm not cutting it off with my construction layer and build my hatching now on the section layer, not switch section. Hatch ANSI 38 is the last one chosen. This is better. Mine was getting a little chopped off by. Oh, and then I gotta make sure I made it annotated. So select it back in, make it annotative, make sure it's selected. Close hatch editor. Okay. So now we just gotta draw this rest and worry about the relief. So the fine details of how deep that goes is what we got to worry about now. So I think I will turn on my construction layer again. And so let's do a little reef. For me, I saw that. It's actually I opened up to page 390. Oh wait, 391 shows them. Yeah. So it doesn't say that it's ANSI 38 necessarily, but it is that section lines and then perpendicular section lines. So what I want to know is on the bottom of Appendix B, where I've pulled some of the data that I've used, right? This one. This Y, I think what I liked is now I haven't referenced these ones. And I think these I put on here because specifically for this, the relief hole be, below the actual fastener in this material. I think I ended up liking this. I can't remember what I said here. What's going on here? Oh yeah, it gets a little bit. Yeah, this is the pilot hole depth. All right, so let me just see. Maybe one of these is more overcomplicated. Maybe this one's okay. This one show, but what I like is that on the bottom. So this is Appendix B, and it has some terminology that you can look here. So we have the screw length. We've already drawn in the screw length. That's what we've got drawn in. We've got it drawn in the correct, so we know that it's 1.5 inches down below there. Then we have what's called the thread depth, which I feel like is what's the initial little like hidden line is maybe going to be the thread depth. And then I have this drill depth, which is really going to be the diameter of the pilot at hole drill size with its little kind of finished point on the end. So I kind of have these, what I need to figure out is like this thread depth and the drill depth. And this is in its simplified form. So if I come over here, oh, this gets complicated. It sure does. So I've got full threads are E. So my design engagement is my full threads. We have like 1.5 inches of full threads. And then we hit this like what they call as allowance A. Of course, P is pitch. It's because they've got a little formula for us here. But really, once my full threads have been drawn in, what I need for allowance A is 5 times P plus additional. And it's like, what the freak? Okay. This is my formula essentially for how much below my fastener I'm going to draw. I think is allowance A. And then I also have this D. I guess I could if I solve this in order, kind of from top down. Let's look at D first. D is the pilot hole depth. And that's kind of going to be the depth where I put a little point on this as well. And so it is E plus A. And so the pilot hole depth is E, the full thread plus A. Okay, great. So I really can't solve that yet because I need to figure out what A is. That's going to be overall. So A is what I need to figure out. It's 5 times P, so this is constant of 5 times P, which is a pitch. So 5 pitch plus additional. Additional to be established locally based on an experience with particular manufacturing environment. Consider 1 to 2 extra pitches. So I'm going to say I'll consider 1 to 2 extra pitches. Okay, so maybe I'll say it's just going to be 5 times the pitch. So that's kind of the relief in the bottom of the hole, I kind of feel like, is actually like 5 pitches. And then it says you can add 1 to 2 extra pitches. Consider adding. And maybe I won't consider adding. Maybe I'll just do that 5 pitches. Or maybe plus 1. 6 pitches? Okay, so be it. Okay, so with that in mind, what I feel like I have is full thread length. I can kind of come up with a new offset line is what I feel like. So I'll pull up my calculator here. We know that our thread engagement was 1.5 through that plate. And then we're going to allow for this kind of relief of these threads below the fastener is going to be 5 times the pitch. The pitch on our fastener is 0.1. Yeah, so I'm going to add that to that. So I'm just going to say, well, let's add my fastener length plus, and then I'm going to do a little, 5 times the pitch 0.1. That's how I'm going to set up that's just me following this little formula. And then I'm going to say plus 1. I'll say plus 1 on the other side of this. Plus 0.1 is the 1 pitch. Consider 1 or 2 extra pitches. I'll just consider 1. And then it equals 2.1. So I'm going to offset from the underside of my head. I'm going to offset that line 2.1. And that's going to kind of be the bottom of the pilot hole depth, which is D in this little formula, which is also kind of over here is the drill depth. And then the only thing we really have here is kind of the actual thread depth, which is a little bit confusing and a little bit vague on what that is. And so if I go back to my worksheet, what it's going to look like when I draw it is I'm going to draw in the pilot hole depth. That's that 2.1. I'm going to offset to get this, and I'll put a little point on it. And we'll look at another little quick cheat sheet on this. I think the one that I did like a 15-degree or something. Technically, the drill depth might have something. I don't really care what that is, but but we can look at a reference sheet on how pointed this is. But and go ahead. Yeah, I think that's a good, hey, that's a good thing. Yeah, that's excellent. We had to oversize our bolt, right? So 2.1 will not be the relief we actually need. Now that's good. Back me up a little bit. And now I need to figure out, well, I had to make a concession here and say like, well, I don't have a 1.875 or 1.88 thread length bolt that I can get. So I went to a 2-inch. So now I need to maybe go back and figure out how much thread engagement do I really have? And I have my drawing. So let's decide. Technically, this probably isn't an inch and a half. It's more than that, right? So let me do a quick measurement of this. So from here to here is 1.62. So it's actually longer because I had to choose a longer bolt. I didn't have their actual size available. So 1.62 is what I should base off my little formula, right? This little thing here. I should go back and change this to 1.62. So let me start this little thing over and do the same. It'll just be a little longer because I had to go with a little longer bolt rather than shorter. That would have been bad. So I'm going to say it's 1.62 plus my 5 pitches times 0.1 plus an additional pitch. So technically, yeah, I want to offset 2.22. Oh, this is so confusing, I know. And that's just going to be this point that I need to put a point on. And then really I have this, which is kind of hard to determine, but let's just get that part in next on my drawing. So I'm going to come back in here. Got my little dimension up, 2.22. So I'm going to offset in the underside of the head. 2.22 is my offset distance. I'm going to offset maybe just this line if I have something. There's a line. That's good. That'll work. I'm just going to turn that to construction. So that's the depth of my that's my drill depth. That's kind of that relief that has to be below the fastener. And I think that is drawn in with dotted. Is it hidden lines? Let me see. Yeah, it's at section though. I'm trying to think if they draw this at section. Let me see what they've done on the assignment. I kind of like this, right? This is kind of where we're headed actually. And you can see they haven't sectioned, they have not sectioned the drill depth as well. They've kept it as visible lines. Let me double check on what they did on this assignment. They drew it as hidden lines. So I feel like you kind of have there's a variation there. I can't remember how I drew it the first time, but whether it's hidden or visible, I think is maybe I'll draw it hidden because to me it's I don't know. It is at section, so I'm leaning towards visible. Okay, I've convinced myself. I, I can't ever decide. And then the diameter of that is what I really need to know, which is I don't have any reference for how wide the drill depth is, but I actually want to show it at that diameter. So let me do one more little. This is confusing, but I need a little piece to like offset. I'm going to try to offset in this area here. All right, so I draw a little construction line over that. I'm going to use this to do the diameter of the drill. Gosh, I love it when this gets confusing. But what I'm going to do is go back to my worksheet. I've got the diameter of the actual drill, the drill diameter in part Y. That's what I'm really defining here is how deep it's drilled. This is the drill diameter, 21/32. So I'm going to pop this up on my screen here. 21/32 is this decimal. I'm going to divide that in half. So I'm going to offset that little line that I just drew. I'm going to offset it this. So that's a pretty ugly. I don't really need to carry it this critical probably, but 328, 125. It's not too hard to remember. Offset 0.328, 125. Oh yeah, I remember it all. So this is what I'm showing here is the drill diameter, right? It doesn't really match anything with my fastener. It's actually this is actually what the drill would. This is actually how wide I would drill this hole in order to cut these threads, which is yeah, I think that's correct. Okay. I'm just trying to think of the relationship between the minor diameter and that. And is it I'm surprised it's not this way at that line, right? I'm cutting threads. It's not.
What I was saying about the different.
That this would be because my visible line would kind of show up here and be down to here. and then we put a point on it here, which I'm okay if we put a 15 degree on it again. Like that's what I did on that one that we did, like this. I think that's kind of what I'm showing here a little bit. I think that, yeah, let me look at my sheet here. It's my appendix, right? I did 15 degree. It could be, yeah, like I feel like this is kind of confusing to make sense out of. I definitely offset to here, and then I put a little point on it. Then I did visible lines. Yeah, and what's really this is the drill depth, which is essentially like 5 times the pitch. We're kind of like a bottoming relief. What this shows, I don't. This is always confusing to me. Like, what is this thread depth? Why? I guess it's actually probably the amount of good threads that I have, and then I don't have really good threads in this area that I'd even be able to get a fastener down into. I feel like what they're showing here is just, yeah, the actual good threads that have been cut, and then they taper off, kind of showing like this. This is kind of an internal thread looking how it would be, is it would have good threads, and then they start to get progressively not good, and then we have kind of this relief on the end. And this really shows almost like a taper tap rather than like a bottoming tap in some ways. That's additionally kind of confusing. But right here. Yeah. And it's actually particular. I know I did mine at 15 degrees, but there is really some particular if we go to this other thread call out sheet, there are those particulars. Like let me just pull it up and show you how particular this could get. It's the thread thing with graphics. So if I go to my files, oh, maybe I already have it up. It was another worksheet I thought. This one. Yeah, this one gets really in the weeds for these particular parts of this. This is this threadbolt handout with graphics. And if I come down here, these are just clips out of different manuals, but here's that A and that D in the diameter, like this one shows. They maybe be at a 31 degree. Your twist drill is probably at this when you actually drill with a drill. These are the ends of the twist drill, 31 degrees, 60 degree kind of included, 62. I think drill depth we've done. See, they drew theirs at 30 degrees. Maybe that's what I actually have. If I mine at 15 is ends up at 30, right? So I've actually drawn to this. Their thread depth they show. That's what's kind and there's anyway, this does get confusing, but I think that I feel like there was nothing I think that was the best. This is the best sheet that shows some of the specifics. This along with this particular page here. I can't remember what I used as thread depth. It's kind of interesting to me. I don't remember what dimension I really used here. I know I can get my full threads, my screw length. I can get my drill depth, but I think this thread depth to me was just a little bit ambiguous in how to draw that. And really all it is kind of a simplified view anyway. So I feel like I just went a few pitches. I didn't see there was any particular like formula to help me get that. So I probably just I just pulled down the major diameter just a little bit beyond the screw length to show that I'm gonna have good threads. Maybe it's like this far. This isn't, I don't can't remember. Let's see. I'll pull up my old sheet now that we're like way over time and spent bazillions of time on this. Let's just see what I drew here. I probably did that as hidden line work too. I don't know. Let's see what my difference in my other drawing is. I've done this one at a time. Let's go to my model and see what I did. 222 is how far I actually did this time. pulled the major diameter out, and why I did 2.12, I can't say for sure. I think I said that this is what kicks out when you do I don't think this is correct. Honestly, I don't, because that's actually what the formula kicks out first. If you're thinking about it being like an inch and a half in, and you do those 5 pitches, you get this. So I feel like this is kind of misdrawn. I really feel like it's just a couple of threads below the fastener that are actually good threads. Um, yeah, yeah, and that's what I'm gonna make I'm gonna make something up here. So I'm just gonna do what I want to do here.
That's the push.
What did it say?
Something,
This is
something that's unfinished thread, paper tap, and
oh, so it says
10 times.
if it was a tapered tap,
Yeah.
and it said the bottoming taps are 5.
Was fun.
There's another one in between bottoming tap and taper tap. Yeah, it depends on the tap. Really, you're going to have like this relief depending on the tap you have available for sure. So I think for ours and just keeping it, keep it simple. I do want to show that maybe that going on. Um, I think I'm going to go like a couple of pitches below the actual finished thread here. But I definitely think I'm not going to be like drawn accurately, perfectly accurately. But I think this is what I'll do. I'm going to offset the bottom of my fastener by like 2 pitches, which is like 0.2. A plug tap is the in-between one. That's and that and that's kind of how we have drawn ours, is almost for like a plug tap, right? Like it's like because we've gone 5 pitches plus one as like a little buffer. And now I'm actually showing, all I'm really showing is that how many good threads I'd have. So if I should have done 5 pitches plus 3, and then I would be able to do this and show oh, that's 0.2, so that's not what I want. My pitch, I'm just saying I'm going to go and kind of show like 2 pitches below this. That's not very much, huh? Because one pitch is is one pitch 0.1? Oh, maybe I'll just do one pitch. My extra pitch that I've added, let's use that for kind of show the end of the threads. But I feel like I have a little homework to do on this myself. And I feel like I'm lucky that I even got this far, because this was really hard to piece together. I remember last year. And I've definitely condensed some of the data, but I feel like I'm still missing kind of how deep would the threads actually be cut. And it really is like what Nathan said, it's depending on the type of tap you're using. And so we don't know that really here. But going master carving. So I'm gonna do an offset like one thread, one pitch, 0.1 below my fastener. I'm gonna turn this to hidden line work. Then I'm going to bring the major diameter down to this like this. Oh, sorry, as hidden line work. So I want this to be like this. This is going to extend over to here. I'll go over to that layer now. Sorry, right here. And bring in the major diameter down. And at least there I'm getting, and then let me turn off my construction line work here. But what I'm kind of showing, and this is, I guess, the real thing to kind of, I think the real stuff to think about here is what's really showing that is the drill diameter. That's really nice to know. I can't remember if they put a line across the bottom or not. They do put a visible line. So let me add one more visible line. They're all hidden. I'm going to do mine as visible because it's just because I feel like I'm at section. That's my argument for it. Is I'm really at section here. So I'm going to show the drill diameter as a visible line because I'm kind of at section. So this is the drill diameter. I have to drill it this wide, and then I can thread this out. And then when I use that particular piece of equipment called a tap to thread that, or that tool, it's going to cut those threads. And then what I'm going to do is I'm going to cut them extra kind of deep, like we chose 5 plus 1. And that's gonna show that I'm going to drill this, and I'm going to cut the threads, and then there's going to be a little bit of a relief because these are a little bit of a point to these tools. So I kind of show it as a pointed finish, even the drill itself, just drilling the hole is going to end up with a pointed finish in the bottom. So that really shows the hole being drilled with a pointed finish. Then I come back and I run the tap through, and as it cuts threads, it cuts good threads in this green dashed area. Anything below this is going to be poor threads. It's there's this like, and that's 5p below that, I think is what I have. I don't know, 5p below this maybe. I don't. This is what's going. That's the finish of it. So kind of a weird, simplified look. Let's hatch this thing though, and then let's decide if we have to spin our hatch. I think that's a better thing to do. Let's see. Go back to my section layer. Now that I've got this drawn in, I should be able to hatch around it. Hatch that with the same material. Yeah, so if I select this, what you don't love about hatching is in order to show the breakup of material, we don't love it to be in parallel or in alignment with that, right? So we want to rotate that, and if I can remember how to do this, it should just be the angle, maybe. Should be the angle. I'm going to be associative. So if I spin this 90 degrees, does that actually spin my hatching? It's funny that this is what I feel like it won't be because we have them going in both directions anyway. It kind of you never get totally out of alignment as good as I would like to. What is Oh yeah, it's like straight up and down. I mean, that's definitely out of alignment, but we don't like our hatching to be like vertical for sure, right? And 180 is going to be the exact same. So there's not a great way to misalign an aluminum type hatching is what you kind of find out, I feel like, is that I don't know, I don't know what the best 60 is not a great hatching degree either. Really, they like those. It definitely breaks it up. I don't know what I end up using. I'll select this for a minute. Let me see. I don't even know if I broke it up too good. I think actually, one thing you can tell is I kind of scaled them differently, and that's not a bad way. Whether that's right or wrong, I don't know. Yeah, if you pull this way or that way, maybe it gets some misalignment. Yeah, with this one, it's like, I mean, technically, I do like the 90-degree difference because it is like the continuous line is this way, then this one is the continuous line. If you get off this, it's kind of broken up. Yeah. Okay. Yeah, and if you do misalign this a little bit, it kind of moves your hatching outside of the boundary, maybe. That's not ideal.
What do you think?
Then you can kind of get some misalignment here. Just so yeah, and that's critical. Just so you don't get like your lines to maybe line up with each other. It might be the more critical. Like this is a tricky one to hatch, and it's just because of the aluminum hatching pattern is what makes it a little bit more difficult to kind of show some differentiation there. But I think that's good. We got visible lines to show that breakup. We've got that. We're going to do some call outs. I think we're I'll probably pull these through. Can't remember if I pulled this I don't think I pulled it through the entire, I think just left it like that. And I have a rogue break line out there. So this thing is ready for a window on my B size sheet, and we'll definitely just do the dog point tomorrow. So I'm gonna get rid of, I think this is probably a viewport that I hate anyway, maybe. Yep, sure is. I'm gonna do my keyway key seat right here. Think at a half scale is what I had yesterday. That's what I put that on as a half scale. So that's that one. I'll lock it. Tuck this in a little bit. And then I'm going to do another rectangular view for this one is going to be up in here. And half scale here, probably bigger than that. I don't know if this fits as a one-to-one scale. Yeah, probably do this as a one-to-one scale. I might need to notate that on my drawing. think I am gonna draw my dog point, set screw horizontal, probably fit it in over here, but so I've got two different scales. I've got a half scale and I've got a 1-to-1 scale. If I do that, I need to title one and show it. Like whatever the scale is on the title block is fine. If I have a view that shows differently than that, I'll need to title it and put that scale in. So I'll probably do that because I do like this 1-to-1 scale here, and I'm ready to notate this now. So I'm going to go in here and actually add some. I'm going to try to finish this up before I call this done, and then tomorrow we'll do dog point. So let's go in and add some text and some dimensions for sure. You can you can refer to what I've done on the little kind of cheat sheet here on our. I go back out to the module. Like I show how I finished mine, but we need to know some of the dimensions associated with this fastener. So we're not going to do a table for this, but you can see how I notated this was I put the thread node in. It's a hex head cap screw. Um, I have put in the clearance hole through the top plate only. So I've kind of made a local note there. I've done the dimensioning for how deep I'm going to drill that and how deep my fastener is. I don't really care if I don't know about this 2-inch dimension if I really need it. I think I'm going to drop it this time around. I'm going to put this in. So I've got some linear dimensions and some call outs here. I think it's pretty common for clearance holes to be pointed to the center of the hole, like the hole center, and then just to designate that this is through the top plate only. The pilot hole, I'm also pointing to the center line, and I'm saying that it goes down so deep. So this is a depth symbol added to the diameter of the pilot hole. So I've got to kind of build these. I think I did these as just multi-leader lines on probably the text layer. So let's go back here and let's start this process. So for sure, I'm going to be on the text layer, and I'm just going to pull a multi-leader. Whether you use it here on the home tab, you have quick access to a leader here as well. But if I just on the annotate tab, there's my multi-leader on the text layer. Let's first call out the main component, which is the fastener. And it's and I'll put its thread node in. So that's a 3/4 dash. I'm not going to put any spaces. 3/4 10 UNC capital letters. Maybe there's a space between 10 and UNC, and then 2A. 2 for general class of fit and A for external threads. Is that right? And then on the second line, I think I just added that it's a hex cap screw. That's the end of that thread note. 3/4 10 UNC. Yep. I did that with my exactly right. I'm on my inch 1.25 text. Yep. Correct. And then if I just think about the dimensions associated with that, it's definitely its overall length. So the length I'm going to notate here, which is going to be, I'll have to pull these back, but it's the threaded fastener length here. I'm on a limits dimension. It must be the last one I used. I'm going to change this to be my standard 2 decimal inch. Yeah. I'm going to go back and make sure that's my loaded one. And probably need to pull these back to actual bag. That'll be fine. Nope, that's not fine. Let's come back. It's 2-inch long. So I've kind of captured the size of the fastener, I feel like. Now I need to capture the size of the hole that's through this plate. So we do that with another multi-leader line. I just point to anywhere on here on the center line. Come out here, maybe you'd say that this is the hole through the top plate. So I need to know that from the diameter of the clearance hole is 13/16. So I feel like I could put that in as a fraction or a decimal. I feel like either way would be okay on this. Technically, we're kind of a decimal, so I'll probably put it in as a decimal, what 13/16 is. And I'm going to say that by diameter too. So I'm going to say it's a diameter of 0.8125. That's 13/16 decimal. Uh, maybe you can say THRU is through, THRU through top plate. If I had a part number, I could call out through part number blah or something. I'm just saying through top plate only because I don't really have a part number. I could say through part X if I had designated that as X, like they did in their print, but I think this will be fine. So clearance hole is clearance, it means it's my watcher spin. Clearance. There is no clearance. Okay, good. I just wonder if there was. This is correct. And then I need to know the drill depth. So I think I've captured that hole. I really haven't captured any materials yet. So how did I capture this in my one that I did here? I'm sorry, I'm in the wrong. Pilot hole. I never really caught the materials actually here. That's kind of interesting. I'm surprised I didn't put material. I think I will add a note that says aluminum. I mean, I know my hatching shows that, but maybe somebody can't identify that hatching pattern right. Could be magnesium. Freaking good point. Yeah, because it is a multi-purpose hatch pattern. Magnesium, aluminum, and aluminum alloys. So yeah, let's at least think of that here. So, I think, yeah, I'm gonna add a couple more things here. I'm gonna add another multi-liter line. Not here though. That's my chance to say, don't do this wrong. Go through the viewport. Let's add a multi-liter. I'm going to point to this plate here somewhere. And I'm going to say aluminum. That's spell it right? Aluminum. Whatever you do, don't do my wrong size of writing too. This is just going to be 1/8 inch. I don't know why I thought I picked mine switched when I went to that as well. So did my arrow. So did everything in mine switch a little bit. It could be because I bounced back and forth. I think it's supposed to be 1.25, 0.125, 1/8 inch. Yeah. So this should be, it's kind of strange to me that it was adding, it's actually a little bit weird. I didn't have that issue before. This is my current text type is this. Even my leader acts like I'm adding it at a different scale right now. Maybe I'm in the other viewport. I think I'm in the other viewports. Let me just I just want to make sure it's I mean one of them is scaled at a half, one of them is scaled at 1 to 1. It could be bouncing me into the wrong one is one that would be why it would be double the size. That's why it looked potentially. Just watch what viewport I went into there. This is correct. See, I was in the wrong viewport. If I didn't pick a viewport and I jumped in, it jumped into the first one I placed probably. So um, but I feel like I also have to designate the other as aluminum as well. That's only one part. Yeah, exactly. Like I'm down here saying this is also aluminum somehow. Maybe I'll make it break up, but Back up. I didn't really put, I just put aluminum, not said the material aluminum. Okay, and then just a couple more things, and I'm done. Let's see. I gotta have the drill size put in, so maybe I'll do another multi-liter for the drill size down here. So this is another diameter of the drill size off my sheet, tap drill size. Real in part Y is 21/32. I'll probably put that decimally as well. Yes, 21/32. So I have to remember what that is. 21/32, 65625, real critical, 65625. Could be an argument to leave it as 21/32, but I can't remember. I've come this far. I'm holding that to super big. Super big. I could sometimes put as a reference. I put it as a reference actually, and this is tap drill size, maybe I can call it. I actually did put my fraction there too as kind of a reference dimension because that's an odd, you know, this is just to show that hey, this looks like it's a really highly critical. This is just me being a little more clear because I'm like, hey, this is a really highly critical 1, 2, 3, 4, 5 decimal places. Actually, it's just a 21/32 drill bit is what I kind of showing that. I don't think I showed that on my last one, but I actually did horrible. But I can put the depth though, but I really don't love that I abbreviated that necessarily. So anyway, pilot hole. I don't know. I called mine tap drill hole. I liked it better on my second time around. Tap drill hole. Tap drill size is what I said. Tap drill size. So I have a couple more linear dimensions to add, like how deep that is. And so you can do that here. If I did that here, I shouldn't have to do a redundant dimensioning though, right? Like to me, I like this better than maybe this linear dimension. So I'm going to add my depth to this. So if I go back into this viewport here, what I'm saying is I'm going to add the depth here. Remember that depth when you bring in those fonts, they kind of mess up your font. So I'm going to put in the actual depth first, which I can't remember what it was. It's 0.22, right? It's actually 2 point. It doesn't sound correct because it's actually not. I'm only drilling through the second. I'm gonna do a quick little measurement here. I'm only drilling through part Y, so that's from here. From here to here is what I'm actually drilling. Does that make sense? Yes, 1 point. I'll do it again because I lost it too before. So, but it's going to be through only through part Y, and it's going to be this drill depth because we've already accounted for those pitches, those extra pitches and stuff. So it's 0.1, 1.84. That's how deep I'm going to drill this one. So I'm saying point, oh, sorry, it's 1.84. In front of this, I'm going to put a depth here though. So I'm going to look that up. If you remember where these are, they're in the other fonts. GD and T is what I'm looking for. Mine went to it. I don't know if yours will, but if not, just type in G up here. And just, I know there's a couple of GD and T's. I'm just using the one that's just GD and T only. Here is the depth, downward facing arrow. I'm going to load it. I know, and that stays up just so you know, it's like loaded on your taskbar. So load it, copy it, place it over here. I just do my control V for a paste. I delete this space. Looks a little bit odd to me the way it lines itself up, but that's what we got to work with CAD. What's in CAD kind of tap drill size. So it's 21/32 down 8.4 tap drill size. That's great. I don't really need to notate that at all. What I would like to probably add on for dimension would just be the linear dimension thickness here of this part size. Because technically I'm showing it's showing it. Anything else I'm missing? I only like those two dimensions. I have my fastener length listed. it's arguable that I could put that in the screw, like I could put that in the title here. Like if I didn't want to show this linear dimension, maybe it kind of helps. Um, Makes sense out of the whole section view that I have. I think I can move this. Do some spacings here, clean out my dimensions a little bit. Still acting weird. Like you're not in the right viewport. Just double check that you're not in the other viewport. Oh yeah. It may just I don't know you if oh, so what I do if I have issues in the annotation it doesn't seem to be like associative for me. I will sometimes flex it, right? So sometimes I'll come out here, just go to your viewport, unlock it for sure, and then just do a flex. Like go from like a half size to a one size. Sometimes that helps it like snap to tension. Maybe not though. I'll come around. I'm a I'm a I'm a be yeah. I'm about ready to wrap mine up. So all I'm doing is just cleaning up, and then I'll come around and look. I think mine is about done. Heck, I got my dimension all messed up here. Back to where I was. I'm giving me issues. Dues. That's better. Okay. I've got aluminum. I've got aluminum.
Make sure you have the right size first, though.
Back to my. I just need to do. I got to do a little viewport correction here myself. It's just size. I'll come around and so finishing my viewport placement. I can't say that I'm gonna keep it at 1 to 1. Right now I have mine at 1 to 1, but until I get my dog point one drawn, I don't know for sure it's gonna stay there. In fact, I haven't even titled this yet, so I'm just gonna save this as it is. I'll at least capture this one, and we'll do the dog point set screw tomorrow, and then I'll just kind of figure out if I gotta label some of these views, change the scale. Um, I'll decide once I get my last one drawn how I can fit everything. So I like that this has multiple drawings on one drawing, and then you have to worry about maybe the scale and how to get everything sized right here. And so we'll worry about that tomorrow. I'm not going to worry about that until I have the next view to deal with. And so, yeah, that's a good place to stop this one. So now I'll come around and see if I can help anybody that's in the weeds on this very weedy assignment. Okay.
Black.